Welcome back to solving systems of equations using graphs. As you look at this example, you'll notice that it is not in slope-intercept form. Instead, it's in standard form. Standard form is ax plus by equals c. Now, there's actually two ways to graph a line in standard form. The first way is to go ahead and convert it to slope-intercept form, which, if you recall, is y equals mx plus b. Or you can solve it by finding the x and y intercepts. So your x-intercept, you have to know your y value is going to equal 0, and we don't know what your x value is. And your y-intercept is going to have a x value of 0, and we don't know what the y value is. Now, to find those unknown variables, we would just plug in plug in a 0 for x and a 0 for y, respectively, to find those intercept points. Now, I find that the slope-intercept method is the most precise way to find points and to find solutions. However, both methods work, and I will show you both right now. So for the first function, I'm going to do the conversion to y equals mx plus b. So we have 2x plus y equals 5. From here, our goal is to get the y by itself. In order to do that, I'm going to go ahead and subtract 2x from both sides. When I do that, this is going to cancel, giving me y equals negative 2x plus 5. I reordered the right side so that my x term was first, just like it is in the formula for y equals mx plus b. Now, if you recall from the last video, I like to express my slopes as fractions. So this would be rewritten as y equals negative 2 over 1x plus 5. Okay, I'm going to go ahead and graph this line. I'm going to go up 5 places for my y-intercept. 1, 2, 3, 4, 5. And then I'm going to use my slope of negative 2 over 1. So rise over run, down 2 units, 1, 2, and then right once, 1, and place my dot. So I have those 2 points plotted. I'm going to have to be very careful when I plot this because I want my line to hit just right. So this is the downside of using the other method is I know I have to be very precise with my lines. Otherwise, it's not going to work. But you can avoid all this by just converting to slope-intercept form both times. But I'm going to show you guys the other way that you guys can solve this problem. The other function, x minus 2y equals 5. All right, let's check it out. So on this one, I'm going to try to find my x-intercept and my y-intercept. The way I can do that is by plugging in a 0 for my y value and then finding out what my x-intercept is. So when I plug in a 0 for y, we'll see x minus 2 times 0 equals 5. Well, 2 times 0 is 0, so I get x equals 5. So my x-intercept is at 5, 0. 1, 2, 3, 4, 5. 5, 0. To find my y-intercept, I would plug in a 0 for the x value. So instead of x minus 2y equals 5, I get 0 minus 2y equals 5. So I get negative 2y equals 5. To get rid of the negative 2, I'm going to go ahead and divide by negative 2. So I get y equals 5 divided by negative 2, which is negative 2.5. So my y-intercept is at 0, negative 2.5. So I'm going to go down 2 units and about halfway to the third one. And you only need 2 points to graph a line. Do our very best to make these line up. And it looks like our intersection point is right here at 3, negative 1. Now, like I had mentioned earlier, The solution when we're graphing using x-intercepts, it's not as precise as using the slope intercept form because it's not always going to be at a nice lattice point. Now, to confirm our answer, if you guys are going to be graphing with the x and y intercepts, I suggest you take your solution and see if it's true by substituting the solution back into both of the functions. So you could do that by plugging in 3 for x and -1 for y. So for the first one, we would have 2 times 3 plus a -1 and see if that equals 5. Well, 2 times 3 is 6. 6 minus 1 equals 5. So we're good there. Then you do the same thing with the second function. So it's 3 minus 2 times -1. And let's see if that equals 5. Well, -2 times -1 is +2. And 3 plus 2 does equal 5. So we're good. So after you've checked your solution, you know that you're right, you're set to go.